This diagram illustrates the hypothetico-deductive model, the core engine of scientific inquiry. It operates as a continuous cycle of knowledge creation, moving through distinct phases: theory, hypothesis, observation, and concept formation. This loop drives the entire process of generating and refining empirical facts. Researchers use it to translate abstract ideas into testable reality, and then use that reality to update their initial ideas. In the applied sciences, a persistent bias assumes this machinery belongs entirely to quantitative research, the idea that only numbers and statistics follow this disciplined path. However, quantitative and qualitative methods are not competing epistemologies. They act as distinct vectors moving across this exact same map. The core difference lies first in where each method enters the cycle. They do not start at the same node. The second distinction is the direction of travel. Once a method enters the loop, it follows a specific trajectory through the remaining nodes. For researchers designing a study, understanding these spatial vectors is critical. It clarifies how a chosen method logically builds and defends its conclusions. To see how this works, we can isolate both the quantitative and qualitative pathways and trace their exact routes through the model. These methodological pathways are the specific logical routes a researcher takes to build conceptual insight. By tracing these routes, we can see how qualitative research functions not as an unstructured alternative, but as a disciplined navigation of this logical engine. Isolating the quantitative vector shows research begins at the top, formal theory. It uses an established framework to dictate what researchers look for. Broad concepts are distilled into specific, testable hypotheses, defining deductive logic. This hypothesis sets strict parameters for measuring variables during empirical observation. Once those observations are collected, statistical analysis serves as the testing mechanism, comparing the hard data directly against the original hypothesis. The quantitative vector completes its circuit by feeding the results of those statistical tests back up the chain to refine the original theory. This loop is built for precision, confirmation, and the incremental refinement of what we already suspect to be true. However, this vector has a structural limitation. Because it is bound by its starting parameters, deductive logic struggles to generate entirely novel theories. It can only test what has already been defined. The quantitative pathway functions as a rigid, deductive loop. It validates existing knowledge within a set boundary, rather than building new theories from raw data. Tracing the qualitative pathway illuminates the bottom half of our map. Qualitative researchers enter the cycle at the observations and concept formation nodes, deliberately avoiding formal, restrictive hypotheses. Instead of testing predefined variables, these researchers immerse themselves directly into rich, granular data at the observation level, allowing the subject matter to dictate findings. Methodologies like grounded theory or phenomenology rely on this raw entry point to capture human experience and complex social phenomena without pre-filtering them. The direction of travel is reversed. The qualitative researcher works from raw observations, moving upward toward abstraction and theory construction. This data-first upward trajectory operates strictly on inductive logic. While the deductive vector is built to test existing theories, induction is engineered for theory construction. Moving from unstructured observation to formal conceptualization requires intense, systematic analysis of the data. It applies its scientific rigor to building rather than breaking down. Ultimately, the qualitative vector arrives at the exact same theory node as the quantitative vector. It just climbs there from the bottom up. Qualitative methodologies are disciplined, inductive climbs. They are the necessary tools required to map unknown phenomena where no prior theory exists to test. The ultimate goal of completing either circuit is to output research findings that can be generalized to the real world. Looking at the split-screen flowchart on the left, the quantitative vector terminates in statistical inference. This relies on mathematical probability, taking numeric data from a sample and extrapolating it to represent a larger population. Qualitative research is often criticized for small sample sizes lacking statistical probability. But on the right, the qualitative loop ends in a different node, analytical generalization. This doesn't extract numeric probability. It extracts core conceptual logic from the observed data. This output relies on a mechanism known as transferability. Transferability assesses whether the conceptual insights gained in one specific study can be logically applied to a different but structurally related context. Because the observational data is deeply detailed, researchers can identify the underlying mechanics of a phenomenon. This allows them to transfer the insight without needing massive, randomized sample sizes. The two vectors simply trade in different currencies of generalization: probability on the quantitative side and conceptual insight on the qualitative side. By focusing on depth over breadth, qualitative research achieves real-world application through the rigorous transferability of its concepts. Locking both the deductive and inductive pathways onto the single epistemological map reveals the complete structure. The diagram confirms that quantitative and qualitative methods exist on the exact same circuit. They maintain strict mechanical differences, utilizing distinct entry points and reverse directional logic. These mechanics produce divergent outputs, yielding statistical inference or analytical generalization, depending on the route taken. Because they operate on the same continuous cycle, these methodologies act as symbiotic elements of a unified scientific method. They are not mutually exclusive. New theoretical frameworks constructed from the ground up via qualitative induction eventually require the broad testing of quantitative deduction to validate them at scale. Conversely, when quantitative testing yields statistical anomalies, researchers must rely on qualitative induction to examine the environment and explain why those anomalies occurred. Engaging in methodological tribalism, claiming one vector is inherently superior to the other, ignores the mechanical reality of how research functions in the social and applied sciences. High-level research requires fluency in both directions of travel around the cycle, matching the appropriate tool to the specific research problem. True scientific rigor is achieved by mastering the complete cyclical engine of knowledge creation, ensuring that both numbers and narratives serve the exact same pursuit of empirical truth.